Feedback occurs when outputs of a system are routed back as inputs as part of a chain of cause and effect that forms a circuit or loop. The system can then be said to feed back into itself. The notion of cause and effect has to be handled carefully when applied to feedback systems. Simple causal reasoning about a feedback system is difficult because the first system influences the second and second system influences the first, leading to a circular argument. This makes reasoning based upon cause and effect tricky, and it is necessary to analyze the system as a whole. History. Self-regulating mechanisms have existed since antiquity, and the idea of feedback had started to enter economic theory in Britain by the 18th century. But it wasn't at that time recognized as a universal abstraction and so didn't have a name. The verb phrase, to feed back, in the sense of returning to an earlier position in a mechanical process, was in use in the US by the 1860s. And in 1909, Nobel laureate Carl Ferdinand Braun used the term feedback as a noun to refer to coupling between components of an electronic circuit. By the end of 1912, researchers using early electronic amplifiers had discovered that deliberately coupling part of the output signal back to the input circuit would boost the amplification, but would also cause the audion to howl or sing. This action of feeding back of the signal from output to input gave rise to the use of the term feedback as a distinct word by 1920. Over the years there has been some dispute as to the best definition of feedback. According to Ashby, mathematicians and theorists interested in the principles of feedback mechanisms prefer the definition of circularity of action, which keeps the theory simple and consistent. For those with more practical aims, feedback should be a deliberate effect via some more tangible connection. Practical experimenters object to the mathematician's definition, pointing out that this would force them to say that feedback was present in the ordinary pendulum, between its position and its momentum, a feedback that, from the practical point of view, is somewhat mystical. To this the mathematician retorts that if feedback is to be considered present only when there is an actual wire or nerve to represent it, then the theory becomes chaotic and riddled with irrelevancies. Focusing on uses in management theory, Ramaprasad defines feedback generally as information about the gap between the actual level and the reference level of a system parameter that is used to alter the gap in some way. He emphasizes that the information by itself is not feedback unless translated into action. Types. Positive and negative feedback. There are two types of feedback: positive feedback and negative feedback. As an example of negative feedback, the diagram might represent a cruise control system in a car, for example, that matches a target speed such as the speed limit. The controlled system is the car. Its input includes the combined torque from the engine and from the changing slope of the road. The car's speed is measured by a speedometer. The error signal is the departure of the speed as measured by the speedometer from the target speed. This measured error is interpreted by the controller to adjust the accelerator, commanding the fuel flow to the engine. The resulting change in engine torque, the feedback, combines with the torque exerted by the changing road grade to reduce the error in speed, minimizing the road disturbance. The terms positive and negative were first applied to feedback prior to World War II. The idea of positive feedback was already current in the 1920s with the introduction of the regenerative circuit. Trevithj and Jensen described regeneration in a set of electronic amplifiers as a case where the feedback action is positive in contrast to negative feedback action, which they mention only in passing. Harold Stephen Black's classic 1934 paper first details the use of negative feedback in electronic amplifiers. According to Black, positive feedback increases the gain of the amplifier. Negative feedback reduces it. According to Mindel, confusion in the terms arose shortly after this. Trevithj and Jensen had made the same distinction Black used between positive feedback and negative feedback. based not on the sign of the feedback itself but rather on its effect on the amplifier's gain. In contrast, Nyquist and Bode, when they built on Black's work, referred to negative feedback as that with the sign reversed. Black had trouble convincing others of the utility of his invention, in part because confusion existed over basic matters of definition, even prior to the terms being applied. James Clerk Maxwell had described several kinds of component motions associated with the centrifugal governors used in steam engines, distinguishing between those that lead to a continual increase in a disturbance or the amplitude of an oscillation, and those that lead to a decrease of the same. Terminology: the terms positive and negative feedback are defined in different ways within different disciplines. The altering of the gap between reference and actual values of a parameter, based on whether the gap is widening or narrowing. The valence of the action or effect that alters the gap, based on whether it has a happy or unhappy emotional connotation to the recipient or observer. The two definitions may cause confusion, such as when an incentive is used to boost poor performance. Referring to definition 1, some authors use alternative terms, replacing positive, negative with self-reinforcing, self-correcting, reinforcing, balancing, discrepancy-enhancing, discrepancy-reducing or regenerative-degenerative respectively. And for definition 2, some authors advocate describing the action or effect as positive, negative reinforcement or punishment rather than feedback. Yet even within a single discipline, an example of feedback can be called either positive or negative, depending on how values are measured or referenced. This confusion may arise because feedback can be used for either informational or motivational purposes, and often has both a qualitative and a quantitative component. As Connellan and Zemke put it, quantitative feedback tells us how much and how many. Qualitative feedback tells us how good, bad or indifferent. Limitations of negative and positive feedback: while simple systems can sometimes be described as one or the other type, many systems with feedback loops cannot be so easily designated as simply positive or negative, and this is especially true when multiple loops are present. When there are only two parts joined so that each affects the other, the properties of the feedback give important and useful information about the properties of the whole. But where the parts rise to even as few as 4, if every one affects the other 3, then 20 circuits can be traced through them, and knowing the properties of all the 20 circuits does not give complete information about the system. Other types of feedback in general. Feedback systems can have many signals fed back, and the feedback loop frequently contain mixtures of positive and negative feedback, where positive and negative feedback can dominate at different frequencies or different points in the state space of a system. The term bipolar feedback has been coined to refer to biological systems where positive and negative feedback systems can interact, the output of one affecting the input of another, and vice versa. Some systems with feedback can have very complex behaviors, such as chaotic behaviors in nonlinear systems, while others have much more predictable behaviors, such as those that are used to make and design digital systems. Feedback is used extensively in digital systems. For example, binary counters and similar devices employ feedback where the current state and inputs are used to calculate a new state, which is then fed back and clocked back into the device to update it.